In this podcast, I'll be simplifying trigonometric equations, and I'm going to do a couple of different scenarios that'll help see some of the methods that you can use to take an expression that could be rewritten in a more simplified form. We may be using this expression in calculus, we may be using it in an equation, but our goal is just to make the problem smaller. So in the first example, if I had the cosecant of x divided by the secant of x, one thought here, and this is sort of the beginning, what you would try to do is rewrite the problem in terms of sine and cosine. So if you remember that the cosecant is the reciprocal of sine, we could rewrite this as 1 divided by the sine of x over 1 divided by the cosine of x. Now what I've created is a complex fraction, and I'm just going to use simple algebra and multiply by the reciprocal, which will give me the cosine of x divided by the sine of x. And if you remember, cosine divided by sine is equal to cotangent. I have come up with a simplified version of the cosecant divided by secant. So I did some substitution, and then I did some algebra, and I ended up with a simplified version of the expression. Now in a second example, I'm going to take tangent and rewrite that as the sine divided by the cosine. I'm going to leave everything else the same. This one isn't quite as easy as the one above, because when you're multiplying a fraction by something that's not a fraction, we're going to multiply the numerators together, make it sine squared over cosine plus cosine. Now I have a fraction plus something else, and I need a common denominator when I'm adding, so I'm going to multiply the second fraction by cosine on top and the bottom. This is going to give me sine squared plus cosine squared in the numerator over cosine. Now, if you remember your Pythagorean identities, anytime you see sine squared being added to cosine squared, we can substitute this with 1. So I'm going to change this expression now to 1 divided by the cosine of t, which is the same thing as the secant of t. So again, I took a trigonometry, I took the tangent of t, replaced it with sine over cosine, then I used algebra, the math that goes with fractions, by multiplying, adding, and then I did the substitution with the Pythagorean identity. Okay, so these were just two beginning examples that I would usually start with in my class. And next, I've just listed some of the possible things that you could use. So anytime you're trying to simplify trigonometric expressions, here's the first thing I did. I rewrote using sine and cosine. So if you have tangent, cotangent, secant, and cosecant, rewrite them. A lot of times we might want to use the algebra like combining like terms, using the distributive property to get rid of fractions, or to get rid of parentheses. Factor, that's another example where you want to you have like a square or something and you try to split it up. If you have fractions, you want to try adding, subtracting, multiplying, dividing, getting a common denominator. Multiplying by the conjugate would be where you've got two terms on the bottom and you multiply by the same expression but the opposite sign. And you always want to remember to simplify complex fractions. And in the last example, I used the Pythagorean identities, which the basic one is sine squared plus cosine squared equals 1. But we also have the tangent squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. Okay. Another thing that we might want to try using is the even and odd identities. So if we have a negative in there, we might want to try to get the negative out. Later on, when you learn sum and difference formulas and double angle and half angle, you can also simplify expressions using those identities as well. All right, so your first gut instinct when looking at this problem, you might think change sine over cosine to tangent, but I'm thinking in this one, my gut instinct is saying, let's add these two fractions together and get one denominator. So I'm going to multiply the first fraction by 1 plus the sine of theta on the top and the bottom, and I'm going to multiply the second fraction by the cosine of theta. That's going to give me a denominator of, it doesn't matter what order you write it in, 1 plus the sine of theta times cosine. Let's not distribute it yet. And my numerator, I'm going to get the sine of theta plus the sine squared of theta plus cosine squared of theta. Okay, now if you remember what I said before, anytime you see sine squared and cosine squared added together, that equals 1. So if I rewrite my numerator as the sine of theta plus 1 over 1 plus the sine of theta times the cosine of theta, you can see that what I have here are two common factors that can cancel out, even though I had it written backwards. So what I end up with then is I have 1 divided by the cosine of theta, which simplifies down to secant. And there's your answer. Now, a lot of times students are frustrated because they don't know how to start the problem, and you really just have to try things. You might try something that doesn't work, and you might have to go back to the beginning and try something else. That's frustrating, I know. Good problem solving, though. All right, here's an example where there might be two obvious ways to start it. And if I give my students something like this on a test or quiz, I might have to grade it both ways. Your first instinct might be do the distributive property. So if you do the distributive property, you get the cosine squared of x plus the cosine squared of x times the tangent squared of x. That doesn't really make the problem smaller though. So if you think I'm going to replace tangent squared with sine squared over cosine squared, that's good because sine squared over cosine squared, the cosine squared on the bottom is going to cancel out with the other cosine squared, and it's just going to leave sine squared. So we end up with the cosine squared of x plus the sine squared of x, which equals 1. Nice. Now, another way that you might have thought about this problem would be to change the tangent squared right away to sine squared over cosine squared before doing the distributive property. That's totally fine. If you had done that and then distributed, you would have ended up with the same solution. But I was thinking actually of one other way, and that would be if you remember the Pythagorean identity, that 1 plus the tangent squared is equal to secant squared. So if you substituted 1 plus the tangent squared with secant squared, and then replaced secant squared with 1 over cosine squared, now you're multiplying cosine squared with its reciprocal, which equals 1. Both methods are very nice and it gives you the same answer, which is what you want. Last example. If I have the cosine divided by the secant plus the tangent. Okay, my first thought on this one is to replace secant with 1 over cosine and tangent with sine over cosine. Okay, now that's kind of nice because I have a denominator on the bottom, a common denominator of cosine. So I have 1 plus the sine of x divided by the cosine of x. Okay, now if I multiply by the reciprocal, the cosine of x times the cosine of x over 1 plus the sine of x. Now it would have been nice if that cosine had been on the bottom because then it would have canceled out, but it doesn't. I'm going to end up with cosine squared divided by 1 plus the sine of x. Now what do I do? Okay, one thought that I have here is if I think about sine squared plus cosine squared equals 1. That's my Pythagorean identity. That one you should know. You should have that down. Anytime you see a squared, think, can I do some substitution with that Pythagorean identity? And notice, if I subtract sine squared from both sides, I end up with the cosine squared of x equals 1 minus the sine squared of x. It's still the Pythagorean identity, it's just rewritten. Now, if I take this and substitute it right there, I'm going to get 1 minus sine squared of x divided by 1 plus the sine of x. Now, how does this help me? Now, your first instinct might be, okay, cancel out a sign on the top and bottom, cancel out a 1. Don't do that. Can't do that. What you need to do instead is factor the numerator. The numerator is a difference of squares. Okay? You have a squared minus b squared equal to a plus b times a minus b. Okay, maybe you don't think of factoring with trig identities, but you can as long as you've got subtracting and you've got two perfect squares. So if we substitute this with 1 plus the sine of x times 1 minus the sine of x and divide that by 1 plus the sine of x, cancel, cancel, and we end up with 1 minus the sine of x. Now we get a two-term expression for our solution, or our simplified expression, I should say. And that's okay. The previous ones all ended up being one answer, okay, but this one didn't. And it might not. Okay, so I've just given you a couple of examples of how to simplify trigonometric expressions. This is usually a section that's very hard for students. Again, go back to thinking. Substitute with sine and cosine, and then do the algebra that you've learned, like combining like terms, distributive property, factoring, work with fractions, and then think about those Pythagorean identities and the even-odd identities that we also know. There's other ones as well, like the cofunction identities and like I said, the double angle and half angle that probably could be used as well. Thanks for listening.